kita nak faham sains tu apa. Adakah ianya didefinisikan dengan satu skop kajian ilmu, kan, ataupun ianya adalah satu metod, kan, ataupun apa yang berlaku dalam sains tu. Dan bila dinyatakan ianya adalah satu penyataan sains, kita kata ini adalah penyataan sains, apa maksud dekat situ? Adakah ianya hanyalah model ataupun konseptual yang kita abstract daripada realiti tersebut, ataupun dia adalah satu statement terhadap reality itself, kan, terhadap benda itu. Bila kita kata dalam sains contohnya ada atom sebagainya, kan, contoh, kan, adakah secara realiti memang dalam tu ada atom, ataupun dia hanyalah satu konseptual untuk dimodelkan pada pemikiran untuk difaham benda tu lah, kan. Tu satu level bahasan lah.
So okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Macam mana nak jawab soalan ni? So hari tu masa kan Prof apa slide datang, kan, dia dikasih, dia cakap pasal yang apa, falsafah sains. Dia ada series of talks, and then the last one tu dia cakap pasal falsafah sains.
Saturday night lah.
Saturday night tu, kan. Dia cakap tu masa the initial parts tu betul. The problem is dalam sains, kan, orang belajar sains tu boleh, they can back me up. Kita tak cakap pasal mauduk tau. Kita tak ada tak belajar, tak ada, kan? Dia macam very roughly, kan. Mana ada kita cakap dia punya ni biology banyak macam ni, tak ada, kan? You just say it's a study of living beings, kan. Essentially, kan. So that's pretty much it, kan. And then sama kat physics, it's a study of physical phenomena. And you go macam okay, tapi semua benda physical phenomena. So dia macam we don't, so whenever what I realise is bila cakap dengan especially orang yang ada latar belakang agama, the way you guys talk ialah korang akan start dengan membadi ilmu tu, kan. Korang ada mauduk, lepas tu korang ada masail, kan. Saya tak cakap pasal benda tu. We are not trained that way. In general lah, we don't talk about the mauduk so much, tapi kita banyak cakap pasal masail. Tapi dalam cakap pasal masail pun kita akan cakap pasal the tools in which we approach these problems. So nak cakap sains ni apa, it's difficult to say offhand exactly what it is, sebab dalam buku falsafah sains pun tak ada yang setuju dengan definition sains. Some people say this, some people say this. So kalau tengok yang Prof. Albert Slan tu, dia ada sebut several conceptions of science. Tapi I guess yang Thomas Nagel yang dia punya conception is good. It is at least a few things. Macam it is at least a method to understand physical reality. I'll rephrase. It is at least a method to understand physical phenomena, and then it makes claim of what physical reality is. So dua ni confirm betul lah about science. It has certain assumptions which is built into science, which is not necessarily explicitly talked about, tapi it gets macam drilled into you as you do the dia punya curriculum tu. So in this sense macam apa dia panggil, in this sense yang siapa nama tu, Kuhn cakap, kan. So kalau baca Kuhn, dia ada cakap satu tu yang dia kata undergraduate program ni macam brainwashing program. In a sense betul lah. So macam you betul, kan.
Beri doktrin bagi.
Dia tak ada belajar, kan. So you get trained to do things, you get trained to solve things in a very specific way.
Okay.
And then the underlying assumptions tu you kind of absorb. Among the underlying assumptions is, for instance, macam everything is mechanistic. You always every physical phenomena must have a physical cause. As an example, kan.
Mechanistic punya cause lah.
Okay, so it is at least physical. I don't know if it is mechanistic, because mechanistic may have a specific meaning. So maksudnya kalau mechanical philosophy used to mean in order for something to move from one to the kalau for a force to move, then it has to physically move, kan. So, macam when siapa nama ni, Descartes ataupun Gassendi ke cakap benda tu. This is why dia orang tak suka Newton. Sebab Newton tak bagi explanation kenapa gravity berlaku, dia just bagi formula je. Kan? So so in that sense it's not mechanistic lah. So if you say mechanistic means yang macam that meaning, maksudnya you have this, and then it's not mechanistic, it's physical lah. What happens physically. Some of the things are really arcane, macam we don't know. Some of the things macam kita kata macam kenapa macam ni? Memang macam tu. So, dan dalam sains macam setengah orang kata it's all rational. It's not necessarily true. There are rational elements. There are also supra-rational elements. Tapi I guess
supra-rational dengan maksud
dia kita dapat daripada fenomena. Kita just dapat daripada fenomena macam
Intuition. Intuition.
Bukan kita cerap lepas tu itu lah. So itulah dia. Kenapa macam tu? Sebab memang macam tu.
Tak boleh terangkan.
Macam contoh macam double slit eksperimen kan. Kenapa macam tu? Dah memang macam tu. tu jawapan dia. So dia as is lah. So in that sense macam I think yang macam the reason, so buku Unintended Reformation tu, one of the claims yang dia ada is so this will go a bit far lah, tapi dia kata macam the reason science became important, one of the reasons science became important according to the book is because bila there was the bergaduh-gaduh antara bukan Catholics and Protestants ni, the investigation of nature is the neutral ground for which you can talk about God ataupun fenomena kan, without being kena tekan lah. So that was one of the reasons kenapa. So it doesn't say macam the Reformation itself causes the scientific revolution, tapi dia kata macam this is probably one of the reasons kenapa it became very important. Sebab you know, dia super lah macam kalau Salafi gaduh kan. And then orang lain macam benda ni so dia buat benda lain. Super je orang yang manusia kan tu. So on the science punya side itself, dia macam tu lah. Tapi in that sense, if you want to take it very generally, it has always been the case yang orang nak cuba faham fenomena alam kan. There is an argument to be made yang kata macam philosophy started because people rejected the explanation that the gods did X, Y, and Z. I think Hazman was saying, I think it was Grayling punya buku kot yang dia cakap macam tu. So that's why it became natural philosophy, because then it became specifically philosophy which relates to the natural world rather than the human world kan. As it goes on, so the methods of philosophy, so if you look at the history on its own, the methods of the philosophers, dia macam continuous daripada you know, theology kan sampai natural sciences, like it's the same. You may have gradations macam, I mean Aristotle for instance was cakap pasal cakap pasal biology kan, as an example kan. So cakap pasal zoology and stuff like this kan. So there is a gradation, and then after that it was developed and so on and so forth. I guess yang macam at some point the explanation of physical reality tu became specialized on its own, and then it became what is known as science.
Prosesnya tu.
Proses dia lah, as it were. Now why that happens tu is a big thing lah. So invention of science says Ikhwan suka benda ni. Dia kata macam at least one of the key things which happened was mathematization. At least I think that thesis is correct. And then Unintended Reformation kata sebab partly because of this, the Reformation thing. So I think there's more than one reason. Tapi then it kind of coalesced into this thing which we then call modern science. So modern science, in some sense, if you look at it from bukanlah objektif, from like a jauh sikit punya pandangan kan, kita kata it's a specific method of studying the physical phenomena. Physical phenomena specifically lah.
Dia jadi language.
Dia hidup sendiri tanpa mathematician. Sebenarnya bunyi kalau dia kata mathematician tu dah menyebabkan ada specialization. So does it mean that all science sekarang ni must be
So this is the thing. I think yang macam I haven't looked at it properly sebab there's like a bunch of papers which talks about this in the 1960s code. So I haven't read this. I think yang macam there's some thesis by Heidegger or something. I can't remember. Tapi there are papers which talk specifically about mathematization and one of these philosophers. And generally, I think yang macam Okay, so here's the thing. The problem with a lot of philosophy of science is it wants one explanation to explain everything. So dia kata macam dia sama macam the theory of truth tau. Like dia kena macam ni tau. Like it has to be pragmatic. All of it has to be. And then you go macam yeah but no. So macam there's no reason for it all to be that kan. It could be you have gradations of things and then you sort of move from one to the other as you know remove certain conditions or whatever. Itu kan biasanya macam tu. I mean that's my own opinion lah. Cumanya I think yang macam in that case there is kalau kita tengok sejarah dia it bukanlah tapi the strongest expression of this came from Bacon kan in the New Organon, Novum Organum. Kalau kita baca, saya tak baca semua, just saya baca sikit je. Tapi if you read the New Organon, dia nak cakap yang the method of empirical, dia seolah-olah dia tak cakap tapi dia seolah-olah nak cakap the method of empirical punya investigation ni is of the same kind as deduction. Dia macam nak satu dia kata New Organon and organon is like a measuring stick kan. So it's like a new standard. So if you want to have a new standard, then your standard might should be at least as good as your old standard kan. So tapi your old standard is certain. And then how do you get a new standard which is also certain? You have to say that this is also certain. Which is why if you so I was thinking about this the other day and I was like, hang on, like is that why the problem of induction is such a big problem? So but then your new standard is not good anymore. Kan? So if you say macam if you want to move your certainty from the investigation which is rational to the investigation which is empirical, you want to say these two are equivalent, then once you have the problem of induction, then your empirical ni dah tak ada lah. So then that becomes a problem with actually grounding the knowledge which is scientific, which seems to work. Okay. So scientific knowledge seems to work. Tapi the grounds in which why it works is unclear. So tu lah. So with respect to mathematization itself, I think because the model is deductive and the closest one is going to be math, so you have like a gradation which goes down. This is my own idea. So like you start off with pure math, which is so pure math is not considered physical science and it's like some weird philosophy thing. It's like something else. And then you have like physics, and then you have like chemistry, and then you have biology, and then so it goes down. Tapi it's always the case that if you have like a mathematical model, it's always going to be a bit preferred daripada you always look at it a bit more fundamental as if it is. So my own understanding of mathematization too at least has two components. The first one is you encode. I tell this in class as well. You encode assumptions about physical reality in such a way that you can either mathematically operate on it, or it is in the form which is already mathematical. And then you use the tools of logic, which is what math is. Okay, so you use the tools of logic to do work on this. So that's why, for instance, as an example, as a very concrete example, how do we know that that light is an electromagnetic wave? So people orang selalu discuss kan, okay, light is a wave or a particle kan? Orang cakap macam tu kan? Okay, light is a wave or a particle. So some of the phenomena seems to show that light is a wave. It doesn't say that light is an electromagnetic wave though. Where does that come from? So the light as an electromagnetic wave come from the derivation of Maxwell's equation using certain tools, certain algebraic tricks to form a wave equation from the form Maxwell's equation. Maxwell's equations were derived from experiments which has nothing to do with light. For some reason, and it seems to work. So what happens is, dia orang dah tahu pasal fenomena magnetism ni for a while. So they were doing separate experiments. Ni ada buku, Fields of Force. Tak ingat pasal siapa, tapi there's like a blue book. They talk about macam mana Faraday was doing all of these experiments. Sebab dalam sains ni pun dia tak maksudnya dia tak static tau. So semua ingat once dah ada Dalton datang dan semua orang terima atom. Mana ada, tak ada. It was never the case. In fact, Planck tak terima atom tau. Planck was like, no, this is wrong. And I'm going to do the black body radiation to show that this is wrong. So that was like what Planck wanted to do. And then he was like, no, it couldn't be made correct. So itu cerita lain lah. Tapi in the case of masa zaman tu, there was a discussion of whether or not things are atoms or something else. The idea of a force field comes, it didn't originate daripada Faraday, tapi Faraday sort of popularized it. The idea is that if you have a magnet kan, you seem to have macam things moving because of that magnet. Now then, therefore, you have a field. So a field is defined, medan kan? Medan ni is defined as something in points in space-time with a specific value. Tu je. Of something. So for instance, kalau kita tengok peta, temperature kan? That's a field. Yang ada temperature 10, 20, 30, that's a field. Kalau kita tengok peta yang ada direction angin tu yang makin kuat, so yang peta tadi tu is called a scalar field sebab dia tak ada direction. Bila peta yang ada angin tu is called a vector field because dia ada direction. So that's what a field is. Itu dia panggil field of force sebab you have these magnets which are having forces and somehow. So anyway, Faraday was doing all of these experiments and somehow Faraday was the first to show yang electricity and magnetism is kind of linked somehow. We don't know why, tapi it's kind of linked. So dia buat yang you have like a conductor and then dia alihkan magnet or something. That's like an experiment. But then dia dapat current tau. So from there they started to investigate and they formed these macam petua tengah kanan lah, all of these rules kan. Maxwell took that, he formalized it into the four Maxwell's equations. So the four Maxwell's equations are formalized in several different ways. Dia ada differential form dengan dia ada integral form. If you take the differential form and you use a specific mathematical identity, so mathematical identity, they are certain in the sense that if you accept the premises, then it has to come out. Sebab dia deduction kan. So mathematical identities are deduction. Given the definitions of this and the operations, then you will get this. So he took the mathematical identity, letak dalam the four Maxwell equation tu, then it pops out, a wave equation pops out. When we say a wave equation, it looks like a wave equation. And then he made the leap yang kata, therefore, light are waves, are electromagnetic waves. There's an additional punya corollary to that. In that, bila dia cakap tu, the speed of that wave is a multiplication of two constants. In other words, the speed of light is a multiplication of two constants. A multiplication of two constants is also a constant. Betul kan? Because it's a constant kan? Okay. The implication being, the speed of light is constant. Which then goes into Einstein. Dengan Lorentz. So that's how it kind of works, because you test it out and then it seems to work and stuff like this.
Tak faham pun macam nak faham
tapi macam kata what works kan, sebab macam falsafah biasanya dia tend to explain apa benda what it. Kalau sains macam orang contoh bahasa Newton, Newton nak terangkan apa itu gravity, dia terangkan buat apa gravity buat. Betul. Jadi
So I guess macam there's a few modes in which benda tu kena buat lah, sebab at the level of theory dia ada masalah under determination kan. Maksudnya the same set of data can be explained in more than one way, more than one theory. Okay. In those cases, generally the preferred, I mean these days the preferred method is to find an experiment. Okay, so let's say you have two theories. Okay, those two theories explain the data yang ada. Okay, now the two theories can be worked on. Maksudnya because they are mathematical in nature ataupun they have a very specific claim, you can derive implications from that, either mathematical or otherwise Okay, so if the two theories provide certain implications which are different, then you can test them. So if the data follows one or follows the other, then there would be evidence to support one theory. That's why kita in the discussion between sama ada cahaya ni zarah ataupun gelombang, dia pilih gelombang sebab eksperimen contohnya double slit tu kan, atau itu hanya boleh diterangkan kalau cahaya tu gelombang. Dia tak boleh jadi kalau dia zarah. So once teori tu dah established, dan kita guna untuk benda lain lah. So that's generally how. In other words, although you can produce all of these theories, at the end of it, it always have to describe physical phenomena. So your goal is, in some sense, you have like your starting points, and then somehow you want to connect your starting points to physical observables. So that's kind of the link which is why these days macam foundation tu jadi masalah sikit, because there has not been a new theory since the 1970s kot. And all of the theories macam there's no new physics beyond the standard model, meaning yang macam macam okay, then what do we do? So it becomes a problem. Ada competing theories, but the competing theories punya explanations tu dia tak boleh explain all of this other stuff. Dia tak ada data support. So macam kan ada satu page kan, dia ada satu buku tu dia tulis experimental evidence for string theory. Kan dia satu bab kan. There is none. Satu je. Dan macam mana kita nak kata teori tu betul?
Tapi maksudnya sebab mungkin pun nak describe something di reality tu kan. Takkanlah kita kata, bila kita kata macam kalau dalam mantik tu takrif durasmi tak ada belahan lah. Durasmi tu sama-sama dia represent benda, jeans ke.
So this is the thing now. So bab ni kan, like pasal takrif ni, it's one of those things which I'm not clear exactly takrif dalam sains ni yang benda.
Ciri dia.
Okay, put it this way, katakanlah okay, kalau genus dengan species ni kan, kalau biology clear lah sikit lah. Kalau biology, tapi even then pun dia sebenarnya on appearance saja. Cuma dalam fizik, my sense is like all of this is like dia hard in so far as it follows it is that. Faham tak? Dia macam okay, what is a wave? A wave is satu gelombang ialah this thing which follows the wave equation. You go macam, yeah, but it has this phenomena kan. So, macam, yeah, but I mean, lepas tu kan, bukan it doesn't explain anything. It's more like a working definition.
What works.
So paling jelas kan, apa definisi saat? Siapa tahu definisi? Okay, apa definisi meter? Siapa tahu dia mula datang? 1 meter.
Ini dia ikut yang testing dia buat dia buat testing
Atomic punya ni.
Atomic clock. Okay, tapi dia mana? Okay, so first kali dia start dengan macam mana dia define benda tu in the first place. So saat tu dia define daripada tahun kan. Dia start dengan tahun. So lepas tu dia kena ada definisi hari kan. Okay, definisi hari. Masalah dia definisi hari dengan definisi tahun is like dia tak tepat tau. So if you imagine sekarang ni kan, kita ada, okay, katakanlah your computer kan, as an example, your computer is gigahertz kan. Okay, so gigahertz is 10 to the minus to the 9, betul kan? 10/9 kan. So the time, switching time between clock cycles tu is 1/10 to the 9, which is 10 to the minus 9 seconds. Oh man, okay. So let's say you want to do let's say you want to set your standard of time. You should have a standard which is at least as accurate as 10 to the minus 9 seconds.
So you need to replicate dia punya masa.
Bukan, maksudnya if you say 1 saat ni kena 1.0000 sampai kuasa ke-10. Kalau tak ada, your errors in your definition would mean that dia tak sampai kat situ. Ingat kan error kan, dalam sekolah kita selalu ajar yang error kan. So let's say you want to measure something and then you have a ruler kan. If your ruler is only like 0.5, it's 1 cm, you can't measure less than 0.5, betul kan? Sama juga cerita dia. So if your definition is not as long as that, maksudnya titik perpuluhan itu tak sampai situ, then how can you use that as a standard? Faham kan? So that has always been the problem dengan the standardization lah. In other words, because we're talking, we have like sekarang ni macam masa dah sampai attoseconds tau, 10 to the minus 16 apa kan, can't remember what it is or what it is kan. So what you need is so in the first instance bila diorang buat benda ni, what they wanted to do was they wanted to go to measurements of mula-mula dari awal lagi sebenarnya dia akan nak standardize benda ni dengan apa yang fizikal pada alam. Satu dia guna tahun, dia guna hari kan. So sama juga meter pun asalnya meter dia ambil 1/berapa entah daripada ukur lilit bumi. Tu asal dia. Tapi bumi tak sama tinggi. Kan? So okay, so then you make katakanlah you have this steel rod. Okay. Ni 1 meter, tak kisahlah apa jadi ni 1 meter. Okay, then you duplicate those steel rods. Then it turns out that the length of your steel rod will change kan, according to panas. Lepas tu berat dia pun akan hilang. Kalau if some lose more mass than others, then dia akan kecil sikit, dia akan besar sikit and kan. So yang SI unit tu asal-asalnya guna all of this stuff, guna these physical things, and it turns out to be dia tak accurate, and then dia tak, it changes. So what they wanted to do then was to go back to the definition to constants of nature. So itu dia guna constants. So in the case of time, 1 second is defined as 1 over some number of transitions in between two states of an atom kan. So itu dia pakai atomic clock kan. So between two states, dia akan the electron transitions x number of times within a second.
Dia tembak atom antara atom dan
dia akan naik turun. So dia macam ni, dia akan naik turun macam tu kan. So within a second, dia ada dalam berapa juta kali lah dia akan boleh naik turun kan. 1 second is 1 over that. So that's defined because that is known. Masa tu, okay. The question then become duration tu apa? So time cannot be defined non-circularly. Semua definition of time is circular. So, tak ada definition yang tak circular. So you want to say time is the duration of something kan? Okay, what's the duration? Duration is two periods of time. Sama. So it's a circular definition kan? Pusing. So tapi the 1 over something tu is a working definition. You can use that. Tak ada masalah pun kena pakai benda tu kan? So just because you have a working definition, then just because you have this working definition, then you can always use it for something else. So
mesti dia tak reveal height tu lah tadi.
Yelah, tapi
boleh kita kata sebab tu yang sains replace filosofi yang
tapi the thing is dia maybe dia circular at the conceptual level, tapi semua orang boleh buat kan.
Sebab tu sains dia replace.
It becomes a standard lah. So it becomes something that everyone can do, everyone can verify in principle. Okay, when we say this, it's not true. Like I can't build an atomic clock. You can't build an atomic clock. Not everyone can do that. You need like billions of dollars in order for you to build that thing. Tapi the idea is that science is in principle replicable between people, and therefore because you can intersubjectively test the same thing, therefore it provides a standard. Faham kan? So whether or not in some sense macam the conceptual understanding may not be as important except for these foundational punya people lah. So you always have levels lah. Macam for me, macam contoh, I do non-linear optics kan. On what I do, what happens on the atomic level does not matter. Sebab we take it as a whole, as a bulk tau. Tapi kalau macam Prof Raymond Uy yang buat quantum optics tu, on his level, it matters. It matters. So there's different levels of my opinion is macam sains ni dia macam layer tau. So you have different levels of description. And each level of description tu dia punya concerns are different and the mathematics are different because certain things macam get smoothed out. Kan macam contohnya apa nama ni saiz bumi kan. Kita boleh kata ada saiz bumi tapi sebenarnya dia tak sama kan. So on the planetary level it does not matter, tapi kat kita ada bukit kena manjat lah. Kan macam tu. So on the definition punya side, I'm not sure exactly what the definitions in science actually are because it's not clear. So at least macam parts of it is like working definitions, parts of it are like hard definitions. At least tapi bila kita cakap hard definition, I'm not sure if we want to say yang the hard definition tu dia sampai kepada mahiyah, dia sampai kepada essence. Sebab it's phenomena. So how can you say kan macam mana nak jadi hard? Tapi the way we treat it is as if it's hard sebab we can operate on it using logical forms, and the logical forms are necessary. So mathematics are logical forms kan, so like logical structure lah. So if the definitions are not hard, macam mana? So unless you want to say it is hard insofar as it conforms to phenomena, something like that lah. Tapi kalau cakap macam tu, then dia jadi nominalis lah, kan? So dia macam I think one of the other things is like I don't know whether or not macam Ikhwan dia akan tak setuju, tapi I don't know whether or not whenever we talk about and the second thing is I don't know if all of the definitions are of the same level. Maksudnya definition dalam biology sama tak dengan definition dalam fizik, sama tak dengan definition dalam chemistry, tu pun kita tak tahu. Like it's not clear. Maybe there's like degradations of the strictness of definitions kan. Sebab like the way kita classify hidupan tak sama dengan the way we define a subatomic particle. Tak sama dengan the way we define a galaxy, tak sama. Kalau dia tak sama, then how can we say all of this is the same? It's not kan?
Betul. Dia selepas tabalik asas tu kan, maksudnya dia berbeza tak dengan natural philosophy, sebab kedua-duanya adalah objek yang melihat ataupun sedang mencerap alam lah. Dan kalau kata tak tahulah, kalau pada natural philosophy dia boleh definekan seolah benda itu benar, statement kenyataan yang natural philosophy kata itu adalah benar terhadap alam sedemikian, inilah yang berlaku, macam inilah penciptaan, inilah perubahan yang berlaku sebagainya kan. Jadi adakah benda tu menyebabkan kedua-duanya bertembung lah?
So natural in some sense macam dia macam specialization of natural philosophy lah. So modern science is a bit more, we don't call it natural philosophy because there's not much philosophizing, in the sense that macam the methods are kind of fixed. So if you go into physics, unless you're doing foundations, you're pretty much going to use the same things. For instance, I told this to my class as well, like if you're going to do a derivation, you're always going to use integration by parts, for instance. This is known. Atau you're going to use this technique, you're going to use like this thing, you're going to use this thing. So some of the things is like very specialized already. Some juga biology is the same, chemistry is the same. Some of the techniques are kind of fixed. In that sense, you don't have that much philosophizing. There is a distinction yang orang buat between the philosophy of physics. Katakanlah you have a philosophy of physics. There's a distinction yang orang buat within like the foundations of physics, which they call the philosophy of physics, ataupun physics of philosophy, something like that lah. So there's a distinction people make like between that. this distinction has to do dengan number one, the macam philosophy of science in general has to the questions within the philosophy of science. So for example, where am I going with this? Takut lari tadi soalan lain. So katakanlah physics on its own dia ada a bunch of axiomatic stuff kan. So some people are looking at the foundations and see if these foundations are internally consistent. Tapi the questions within philosophy of physics, as an example, they are not the same as the questions within the philosophy of science in general. Not necessarily the same. So for instance, macam philosophy of physics tak cakap pasal problem of induction tak. I mean it's not a problem within so dia cakap pasal benda lain kan. So now whether or not here's a bit of a problem now dalam sains kan, there's always whenever you do an experiment, a lot of the things dia sebenarnya bukan primary intelligibles, dia bukan apa dia panggil makulatul ula kan. Dia bukan, dia sebenarnya secondary. Dia sebenarnya secondary intelligibles. It's objects of logic. It's not objects of experience. Sebab makulatul ula tu maksudnya direct experience kan. Okay. So let's put it this way. Bila kita tengok kamera infrared, kita nampak infrared tu. Tak kan? So kalau kita nampak infrared tu, macam mana kita tahu dia infrared? So there's a level of abstraction. In other words, in order for us to say that the infrared camera corresponds to something extramental, we have to have a series of assumptions, a series of like structure, which allows us to take physical phenomena and interpret it in such a way that this is therefore that, including that light is an electromagnetic wave. dia benda tu necessary, otherwise it doesn't make sense. Otherwise kita tak boleh cakap benda tu kan. So in that sense dia jadi macam dia bukan necessarily, dia macam tengah-tengah. Dia macam so whenever we say something is true, dia tak clear sama ada it is a statement of epistemology ataupun it is a statement of ontology. Certain things are statements of ontology when at least if we can see it. So for instance, macam bila diorang kata I don't know how many, how familiar people are with Galileo Galilei dengan apa nama ni tu kan. So one of the reasons kenapa diorang tak setuju dengan Galileo tu was not necessarily just kan Galileo kan ada teleskop kan. So teleskop tu dia
metafizik
So okay. So let's start from the beginning so people get semua orang faham kan. Otherwise in Aristotelian cosmology you have your earth and then you have spheres around it. Okay. So ni sama dengan Ibn Sina kan, semua kan sama lah. So the first sphere is the sphere of the moon. The first sphere is the sphere of the moon. Everything under the sphere of the moon is composed of 4 elements. Everything beyond the sphere of the moon is composed of the
metafizik, celestial lunar,
sublunar dengan
alam ulwi.
Dia the fifth element. So that is called the ether. Orang dengar AETER, THER, ether tu kan. Ataupun quintessence. So kalau pernah dengar perkataan quintessence bahasa Inggeris tu, dia datang dari situ quint tu 5 kan. So quintessence is the fifth element. So the sublunary world tu is divided into four elements, and you have the 4 humors kan. And then you can move from one element to the other element. Tapi it has apa nama ni, kalau Earth is at the middle of the universe, and then you have water, and then you have air, and then you have fire kan at the end. Now then the way Aristotelians explain kenapa contohnya kayu timbul kan dekat air, dia kata sebab kayu tu is a composition of the 4 elements. So dia ada angin, dia ada whatever lah. So sebab tu dia terapung walaupun dia lagi berat kan. That also gives you an explanation of why things move. Sebab things go down because it's supposed to go down. Yang tu dia panggil theological whatever lah.
Earthly element punya ni.
Earth element kena jatuh kan. So this is also why this is a explanation dan kenapa dia tak setuju dengan the Epicureans who initially propose the atomic punya conception. So the atom was prior to Aristotle. And then there's Democritus punya teori. Aristotle sanggah teori tu. And then Epicurus sanggah balik. So the Muslim punya atomists have more in common dengan Epicurus daripada with Democritus lah, cerita lain lah. So anyway, so the idea was macam the ether does not change because everything in the ether is perfect. That's why it's spheres. This, according to Aristotle, the sphere is the perfect shape, kan? Okay, so this was then taken up by the church, and then this was I'm not sure exactly how, tapi I would have guessed it started bila Thomas Aquinas sort of made Aristotle acceptable to the church, because before Thomas Aquinas, Aristotle was not acceptable. After Aquinas, it was acceptable. So we would say one of the key figures is Thomas Aquinas.
Nominalist tu start masuk lah.
Nominalist was later. Nominalist started with probably Duns Scotus dengan Occam. So that was later. Thomas Aquinas probably about 1 century before.
Cuma Aristotle dimasuk tu pada aspek dia terima juga yang adanya konsep earthly.
So dia terima that cosmology tu. So cosmology used to mean the study of everything, kan? The cosmos is what exists, kan? So sekarang ni dah benda lain lah, tapi it used to be that. So bila siapa nama ni, Galileo, dia guna teropong dia. So the thing is this, teropong ni kan, sebab sebab bumi ni bulat kan. Kalau kita guna teropong untuk tengok ke depan kan, there's only so much you can look out for. Sebab after a while dia akan jatuh kan. So the power of teropong tu sebenarnya tak perlu tinggi sangat. Faham kan? Sebab lepas daripada tu, kalau kita buat power tinggi, apa guna dia? You're not gonna see anything. Kan? So that's why Galileo kena buat teropong sendiri, sebab no one's gonna be crazy, like they will say, why would you want this? So like doesn't make sense. No one's gonna sell that. In the same way, macam no one's gonna build an LHC kan. If you want to do that, then you have to build it yourself. So dia buat benda ni, and then dia tengok dekat ni lah, the heavens. So the first problem was, if the theory was that if the cosmology was everything revolves around the earth, nothing should revolve around itself. Maksudnya kalau ada matahari kena pusing macam tu lah kan. Kalau bulan kena pusing macam tu lah. Bila dia tengok Jupiter, dia nampak ada bulan. So that's the first problem. Second problem is ada comet. So second problem is, okay, kalau ada comet, number one is a change in the fifth element tu, and secondly, macam mana comet tu jalan between apa tu kan. Sebab comet tu lama kan, it travels kan. So they knew yang macam, it's gone past this, so the way you would do these measurements is you would take a parallax. In the same way, kita tengok ni kan, kita tengok lampu ni, dia nampak macam ni kan. So kalau kita gerak sikit, dia nampak lain sikit. So that's a parallax measurement. So if you know your angle and you know your distance, you can use Pythagoras to figure out how far it is. Kan? So that's still how we do all of our measurements of space. Sampai sekarang pun kita guna teknik yang sama, cuma canggih lah. So they knew yang macam, okay, this is and then these measurements once mula-mula Galileo nampak bulan tu, he published it in like a Latin punya book. So semua orang duk tengok semua orang duk buat teleskop ni, semua orang tengok, and then bila nampak komet tu, dan dia ada masalah lah. Kan, then your cosmology macam mana nak ni kan. So dah runtuh lah. So this becomes a problem, and then macam you go, then you have to have a new explanation of how the universe is. Itu yang jadi masalah tu. So okay, so now church punya cosmology tak ada. Then what do we do? What do we do macam itu? So biasanya orang kata, in popular imagination orang fikir macam, kalau lepas dah tak ada orang dah buang semua kosmologi ni, dan automatically pergi dekat heliocentric. Sebenarnya tak. There's a bunch of models in between sebenarnya.
Okay, sampai
so orang kata macam tak, sebenarnya dia tak pecah lah, dia tak ada glass lah sebenarnya. Adalah macam-macam explanation keluar. Tapi
cuma adakah penemuan tu akhirnya itulah meruntuhkan natural philosophy?
dia jadi specialized. Tapi dia punya underlying assumption tu shifted lah. It shifts several times. So from that cosmology, you change it. Tapi I mean, so for instance, macam Aristotelian causation ada 4 kan? Kesebaban ada 4 kan? All of physics effectively paling banyak pun 2. Paling banyak pun 2. You have 4, you have the formal, the efficient, the apa lagi? Ingat lah.
Paling ingat masalah kan dari yang ilah wa'iyah dia punya sebab dia.
Sebab 4 kesebaban kan. Formal, efficient, apa lah?
Bentuk dia.
To form.
Tu dia punya orang yang buat tu.
Betul. The final.
Tapi dia punya final tu yang sebab dia.
Sebab tu.
Tapi dia punya bahan.
The material, betul. 4. Betul lah. So material cost, formal cost, efficient cost dengan final cost. Final cost ni confirm tak ada.
Tak ada kan? Bukan sebab itulah bukan masa sangat kita nak faham fungsi.
Tapi but you're presupposing a purpose. Kadang-kadang kita cakap as if ada tau. Especially dalam apa dia panggil? Dalam biologi, dalam evolusi. Survival of the fittest. Kadang-kadang cara kita cakap tu as if ada final cost. Mana fittest? As if kan. Tapi sebenarnya tak ada sebab it's blind. Kan blind kan? People say blind watchmaker, whatever it is. So final confirm tak ada. Formal form lah. Mana ada orang cakap pasal form? Random lah. Efficient lah. The efficient cost is what causes something happen. And then material pun mana ada dah pun. So paling pun 2. So sebenarnya all of the study of nature within like natural sciences is effectively a study of efficient causes, and you posit a formal cause and a material cause. These two are like your material cause is given because you assume everything is material, and there's nothing non-material lah. And then you sort of say, in the case of physics, you may say, well, this is in this form, and this is this specific form. Then therefore you have your maybe 3 tapi most likely 2 lah. Dalam bayu mana ada kan? Tak ada cakap kan?
Kalau daripada pendapatan moden, adakah maksudnya semua benda tu betul macam Sinan cakap ataupun Aristotelian punya part for elements, for basic elements tu kan sekarang dah reliable, menggunakan itulah basic elements yang ada. Adakah itu memang dah totally wrong?
Yes, that specific case memang tak ada.
Cuma kalau macam sebab dia punya saya baca Ibu Sinan ni dia bina daripada situ edit dia.
Dan menjadi workable lah kan. Dan
workable in sense lah. Adalah kita semua workable at semua condition kan. Tapi macam adakah means itu adalah satu interpretasi yang salah ataupun sebenarnya dia tak cukup di-explain dengan
tak matang satu.
Dia if you're gonna like study only the efficient causes kan. Kalau kita study efficient causes you're gonna get very good at it. Faham kan? So macam if you get very good at it, like you're gonna find things which are wrong in previous explanations. Kan? Like logik lah. Macam contoh kalau orang draw kalau orang lukis satu peta tak, kita rajin nak pergi cari sesuatu jalan kan, mesti ada salah kan. So it's not as if yang four elements tu is wrong in that the world, although it seems to be composed of these things, these are not the ultimate punya. Dia macam kata, dia macam it's an emergent categorization as it were. So intibari lah. Kita kan tu lah. So under that you have atoms. Under atoms you have those things. Some of the phenomena are emergent. Emergent ni, it's one of those things which I don't think macam people macam kata appreciate. Emergent ni maksud dia from constituent punya components, a new phenomena occurs. Contoh emergent, dia ada banyak lah emergent kan. Contoh emergent ni ialah basah. Basah tu is an emergent property. Basah tu on its own does not exist dalam molekul air. Tak ada. Kan? Basah, property basah tu dan licin tu, dia tak wujud dalam molekul air yang membentuk air.
Kalau saya kata basah ni adalah gabungan antara elemen protokoh tu. Buat apa? Air dengan tanah kot. Dia antara dua. Maksudnya
tapi kalau contoh dalam kalam dia explain basah tu sebagai arak kan, macam accident kan. Tapi tak, kita tak kata basah tu accident. Basah tu is an emergent property. Dia lahir daripada interaksi antara elemen molekul air tu dengan benda lain.
basah sama.
Basah tu property basah. Dan licin pun sama. Tajam pun sama.
Kering kok dia pusat. Kering.
Lembab. So some of the fenomena tu kita boleh explain now at this level, tapi kita nak pergi bawah lagi, so faham tak? So what's constitute the smallest element, for instance. Kita pergi bawah lagi. For instance, sekarang ni tak ada kita tak tahu apa saiz elektron. Maksudnya, for all intents and purposes, elektron ni tak ada saiz. Maksudnya, can you imagine something without a size? It's like a point particle, whatever that means. We don't know what the size of a photon as well. Tapi it seems to exist. It seems to exist. So all of our instruments have not been able to figure out what the size. In other words, we have an upper bound. So katakanlah, even if we assume electrons have a size, katakanlah dia macam bola kan. Even if we assume this is the case, there's an upper bound. Maksudnya dia mesti kecil daripada sini. So we have not come to the point ni kita sampai situ.
Yang habis.
Yang tak boleh measure. So dia ginilah, macam okay, let's say katakanlah you have a watch kan, katakanlah kita punya kenapa, okay, I'm just gonna explain kenapa benda ni, kenapa tak boleh measure pula kan. Katakanlah kita punya saat tu, dalam satu saat kita boleh ukur satu saat. Kita ada light pulse yang 0.1 saat. Okay, macam mana kita nak ukur light pulse tu? Macam mana kita ukur? Macam mana kita nak ukur light pulse tu actually 0.1 saat? Kita tahu dia kurang daripada 1 saat kan? Boleh tak kita ukur kurang daripada tak boleh kan? Okay, so they have like clever ways of doing things. For instance, sebab attosecond ni tak boleh ukur, so generally dia akan pecahkan dua, lepas tu dia akan interfere balik. Bila dia interfere tu, the way it interferes, so will tell you panjang di mana, banyak mana. Tak, dia akan pecahkan light tu. Sebab light pulse kan, light pulse is like classical, and then you split it into two, and then you bring it back. So this is a lot of the way, macam the way we know femtosecond lasers and whatnot are measured using, because dia tak ada jam yang setepat tu.
Jadi so, kena sandarkan pada sesuatu,
pada dia sendiri. So you go like, so in order to get that, dia ada macam a layer of abstraction lagi, matematik dia. Okay, so T sama dengan okay, so ni formula ni kita pakai untuk mendalah ni. So that's why it becomes difficult at some point, macam you get to all of this measurement issues and whatnot kan. Ultimately, a lot of the things yang ada is ratios kan. So if you think about it, if for instance, katakanlah tadi kita ada definition saat kan. Okay, kita tahu yang cahaya is constant, betul kan? From the definition of the second, you can derive a definition of a meter, kan? So from that definition, you can use blah 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 blah. Tapi from your definition of a meter, 2 meters is a ratio, kan? 2 meters is just 2 of that, kan? It's just a ratio. So a lot of things are ratios. So sebenarnya we take it as if it's absolute, as if they exist. I mean, fi kharij mana ada, we don't know.
Ibari
there is so tu lah, macam then some in science dia ada macam some certain axioms macam dia tak berapa clear. Benda ni macam susah nak nampak to be fair. I mean, it took me a while to actually see this. For instance, Newton's first law, kan semua tahu kot Newton's first law. Newton's first law presupposes absolute space. Newton's first law cakap apa? Semua yang pegun akan pegun kan, yang bergerak akan bergerak dengan hal laju yang sama kan. Okey, pegun dengan bergerak with respect to what? Macam dia tahu dia bergerak sebab kalau kita bergerak dengan hal laju yang malar, kita tak tahu pun
Benda tu bergerak.
Kan? Kita mana kita nak tahu? So kalau pegun dengan bergerak with respect to what? With respect to
Ada ilmu lain lah.
dia kena ada absolute space lah kat belakang tu. Satu dia gaduh dengan Leibniz. Leibniz kata mana ada semua ni relational je. So tu yang macam ingat 2 tahun lepas yang ada gaduh antara bukanlah gaduh macam orang latar belakang sains kata space time ni wujudi. Orang kalam kata itibari kan. Itibari tu Leibniz, wujudi tu Newton. Tapi first law tu memang dah presuppose benda tu. Dia wujudi lah. Tapi macam nak check? So kalau baca dalam buku siapa dah nama dia, dia kata memang tak ada cara nak check. Memang sama je. So kalau tak boleh check kan, how are you making these metaphysical punya claims lah?
Tapi dia works kan. Itulah
Tujuan dia.
So if it works, macam whatever kan, like who cares?
Jadi sains tak kisahlah apa yang betul.
Tak juga, ada orang kisah, ada orang tak kisah. Engineer contohnya, engineer tak kisah, orang lantak ada absolute space ke tak, aku nak bina bangunan je. So
nak makannya baik tak apa lagi. Tapi kalau adalah masih jadi doktor kata fizik and mungkin bio sendiri dia ada lain-lain filosofi semua ada lain filosofi yang berbeza daripada filosofi of science. Kalau filosofi of science Hakim lah dia kata kan ada cerita macam mana pula kenapa suddenly tiba-tiba ada so-called social science yang mana kita boleh kata this is science social. Kalau ikut susah juga nak kata manusia ni lagi pula kalau nak dia ada ukuran atau kata ada she's course. Susah juga nak kata benda yang dalam philosophy of science tu.
So first comment pasal philosophy of science tu, dia ada general philosophy of science and then dia ada specific philosophy of science. So dia technically dia macam satu the general philosophy of science tu masalah dia sama untuk setiap sains. Tapi for each one of the sciences tu dia ada masalah yang spesifik. Contohnya bio mungkin definition of apa nama ni species. Contoh kan what constitute a species sebagai contoh kan. So that specific for biology. Kita orang tak main, kita tak pakai pun benda tu sebab we don't care. So in that sense, you have the overarching philosophy of science, which masalah-masalah kat situ includes benda macam realism, so scientific realism, whether or not the theories that exist exist extramentally. So that's realism kan. Ataupun semua ni
Konsep.
Theories of truth pun masuk dalam tu. So whenever macam Kuhn apa semua ni, these are like trends within the broader philosophy of science, and then you have the smaller punya. So what I would read, a lot of it is like either the larger, some issues within the larger philosophy of science ataupun very specific issues within philosophy of physics.
Realiti scientific realism ke bukan?
Okay, so sebelum jawab, okay, so I don't know, tapi whenever we do things, it's as if it is. Faham tak?
Workable.
So maksudnya macam
orang kata macam contoh teori Newton boleh digunakan banyak benda, tapi akhirnya
yelah, betul, put it this way lah, macam even if we say teori ni bukan real kan, tapi we act as if it is. Masa kita buat kerja. So otherwise macam mana nak buat kerja? Susah kan? So if you don't think that your theories actually describe something in extramental reality, like you would not use it kan? So
Kalau orang yang claim macam tu, dia tak buat ke benda-benda tu soalan?
tak, itulah macam in some sense macam so macam bila dia orang cakap dia cakap something tau, and then bila dia orang buat macam ya tapi kau buat ni kan, so
Dia buat yang workable ni tadi.
macam contoh kan, let's say lah, dia kata macam benda ni bukan realis kan, and then you want to say that time is relative, that's an ontological punya claim,
Statement.
kan macam so you have to say that it's at least real lah to a certain extent kan.
Dia nilai pula.
Because it's measurable kan. So benda ni so on that specific case memang kita ukur. Like dia orang buat eksperimen, ada dua atomic clock, identical atomic clock, satu letak kat bumi, satu lagi bawa naik kat tebang. Kat tebang tu memang lambat. Dia ukur, nak cakap apa? Betul kan? Nak cakap apa? So what are you going to say? Like you going to say your theories are wrong? You're not going to say your theories are wrong. Clearly it's correct. So tapi does it mean that all of your theories are wrong? Maybe not. So most of the time I would say yang macam it's apa dipanggil lah? Allah, there's a term for it. Fallibilism is the term. It's dia macam fallibilism ni macam fiqh punya apa? You are correct with the probability of being wrong kind of thing. So, kan dalam fiqh macam tu lah. So kita betul kau, tapi kau mungkin betul juga, tapi mostly kita betul lah. Macam tu lah lebih kurang. So we are mostly correct, maybe we're wrong at some point. So you
Baptizan.
Baptizan. Macam tu lah. So most likely because you have to explain kenapa it's so successful. Otherwise it's a problem kan. So and satu, nombor dua, you have to sell the story lah. Macam sains mahal kan. So macam you have to sell the story to people.
Success story lah.
You want to get money kan. So
Datang ke tulisan lah.
Bukan hanya tu sebab tengah cuba tu.
lagi satu. So for the case of social sciences, I think macam this is relatively new. In the sense yang macam maybe in the 20th century kot, yang dia orang betul-betul mula cakap pasal social sciences.
Legal dengan lain-lain yang start the thing kan.
Wallahualam, tak tahu exactly. Tapi essentially they try to use scientific methods within a social context. So it's very narrow lah in that sense.
Orang tolak pula social science, reject this method dengan scientific method, cannot apply.
Define.
Tak semua, tapi the statistical methods memang dia guna.
Statistik.
Boleh jadi tak positivist kan? Boleh jadi tak. Cumanya on the specific case of social sciences, I think yang macam if you look at the trajectory tu, like abad ke 18, 19 lah baru dia start push lah. Maybe 19, maybe 20 kot.
Baru ni.
Mana ada sebelum tu kan semua humanities.
Ya.
Kan mana ada orang cakap sangat.
Like sebab macam kenapa why do you call it sciences kalau social science?
Sebab there's an inversion in the ontological punya pyramid. There is whenever we talk, there is always an ontology and there's always an epistemology. Semua orang ada, kan? It used to be the case, yang paling tinggi ialah Tuhan, paling rendah ialah bumi kan, alam kan, and then dia terbalik. And then dalam kajian alam tu paling tinggi ialah sains. That's pretty much it. Kan, like it's true kan. So sebab tu kadang-kadang kan macam sebab tu kadang-kadang kan macam orang tak perasan tau. So you go macam sains kan, bila kita cakap pasal sains ni, scientific fact ni Juan nak cakap, scientific fact sebenarnya it's a synonym of truth. Betul the work that it does, dia tak lah, tapi the work that it does is sama. Betul kan? Kalau cakap, ni fakta sains, betul lah tu.
It's a truth. So dia ada ontological status lah.
Pada kita fikir lah, yang kita fikir lah. Tapi tu macam subjek, macam dia, in a sense dia serupa macam kalau kita cakap apa dia? Ni datang daripada Quran. Betul lah. Kan? As if macam tu kan. As if macam tu. Well, yelah adalah benda-benda lain kan. Tapi whenever we kalau orang kata so very specifically macam bila kita cakap macam evolution is true. What they want to say is evolution is a fact. What they want to say is evolution is true. Kan? Itu je nak cakap macam mana lain. So you have this. So once you have that, then you want to use the same methods for the study of everything else. Sebab tu dia orang Tuhan pun dia nak ni kan. Isn't it weird? Macam what would a proof of God scientifically would look like?
Okay.
Kan? Okay, so if you define God as something which is unknowable, what would it look like?
Dia tak adalah dalil saintifik kepada Tuhan sebenarnya.
Bukan dalil. Okay, so proof tu, kalau kita kata kita nak guna scientific method kan, and you've defined God tau as something transcendent. Transcendent maksudnya unknowable lah. Okay, how would you use the methods of physics or physical reality to investigate something unknowable? Unless benda tu datang daripada dia.
Kalau lah sebenarnya nak scientific method ni nak kira knowable, dunia unknowable ni tadi tak boleh lah.
Tak boleh. So the question is, okay, you want a proof of God. Contoh kan? Okay, what would it look like? Do you want to see God? Is that what you're saying? Okay.
Measure God.
You want to measure God? Is that what would it look like? Like, let's say you measure something. Okay, what would it look like? Like, this is God or whatever it is kan? Takkanlah, tak logik kot. So sebab tu macam kalau kita tengok kan, macam bila kita dalil kan yang dalam Islam tu kebanyakannya dia sains, SIGN kan. Dia petunjuk, dia bukan macam cerapan. So dia bukan cerapan kan. Sains is cerapan kan. So dia bukan cerapan.
Jadi apa kita kata scientific proof of God?
Depends on what you mean by proof. Tu yang Prof Falsafah kata, if you want to talk about if someone asks you to say proof the existence of God, tanya dia 3 benda. Dia kata, Prof Falsafah kata, what do you mean by proof? What do you mean by God? What do you mean by existence? 3 benda ni dulu. Dah ada 3 ni baru kita boleh bincang. So, kalau selagi 3 ni, so biasanya bila orang cakap macam tu, at least one of the 3 is presupposed. So bincang lah, okay, what do you mean when we want to talk about the proof of God, existence of God and stuff like this kan? It could be the case sebab this is one of those things juga. Macam I realise dalam sains pun banyak je, dalam sains pun terima sebenarnya, although dia kata yang semua orang boleh test, hakikatnya bukan semua orang boleh test kan. So banyak benda tu dia ambil on khabar je. Paper tu khabar lah.
Authority punya
kan khabar lah. Apa kadang-kadang ahad lagi.
Tak ada otis. Kalau sekarang ni ada yang dia panggil Islamic philosophy of science. Dia kata dia beza, dia punya pemahaman dia adalah interpretation of data tu yang menyebabkan it's called Islamic philosophy of science. So macam mana sebab dia bila kata philosophy of science ni can be relate to data tu bisa scientific method, but dalam masa sama the interpretation of the data dan juga method ni pun boleh jadi berbeza. So
method okay, gini lah. So let's talk about method. Method is very difficult nak tukar sebab honestly kan, if you work in a lab, those are the methods which work. Meaning macam kita test banyak benda tau. So I had that discussion macam we do things in a certain way, and I ask kenapa kita buat macam ni? Why do we like the pulse of the electrical signal coming into the electromagnetic modulator has a specific shape. Dia kata, wow, they tried everything else and this is the one that works. So
Power ataupun punya falsification dengan verification, dia tak affected. So dia kita ada assumption awal.
You always have assumptions. The question is sebab tu I think yang macam the correct way of understanding the mindset of scientists is not necessarily realism ataupun anti-realism. It's actually fallibilism. That you might be wrong, tapi so far as you know, you're correct. Sebab it adheres with data. Popperian is false. No one does that. no one goes into a lab try to prove themselves wrong. Very few people lah. Very few people lah. Sebab you're not gonna what you will likely do. Sebab I mean dia lebih daripada seorang tau. Saintis ramai kan. So there's like communities kan. So like kita akan follow satu mazhab lah. Let's put it that way kan. You're not gonna find ways to prove yourself. You're gonna find ways to prove them wrong. You're gonna find to get experiments to see you are correct kan. So you're not gonna find like because there's a million ways in which you can be wrong. There's only one way. You're probably like 10 ways in which you can be right. So you might as well just concentrate on this because there's like you have limited time and whatever. So and then a lot of people they're not engaged in that anyway. So people like me, for instance, we don't engage in proving stuff wrong. But why would we do that? Especially if you're macam a lot of research is also technology kan.
Dia kata bila tu akan bila trigger bila sesuatu data tu provided else, maksudnya dia bertentangan dengan teori tu kan. Tu yang akan ada dua pilihan lah, maksudnya kita
verify
data cara.
Okay, so dia macam ni tau. So I have like direct experience of this. We had so the diameter at which a specific effect was supposed to occur was say 700 nanometers. About 300 nanometers before that, something else occurred, and then it kind of merged also. Ketika if you have a main line, so tiba dia keluar ke sini, dia jalan keluar ke sini. Okay, so that data sepatutnya kata teori kau tak betul lah kan. Okay, that doesn't happen. So you explain it and some other way. You normally explain it some other way. It's very difficult for you to actually bukan disprove. It's very difficult for you to just totally reject the old paradigm, like a established paradigm. Sebab the established paradigm would have had so much evidence. So what you typically do is either you explain it other way ataupun you add some sebab the thing is macam the system macam dia kan semua abstraction kan. So when you abstract, you always assume that these are going to be your main effects kan. So yeah, these as your main effects. You can always add other effects yang kecil-kecil tau. Tapi these effects can be significant when the right conditions are there. So you add je lah kat situ. You add kat situ. Kat situ lah. So you can always add lah. So that's kind of how it normally happens, unless you have macam case quantum tu lah. So dalam case quantum tu memang serius lah. So that's serious. Sebab no one can explain it.
Contoh case pun sebelum datang Einstein pun sebenarnya Newton punya gravitational teori tu pun ramai dah persoalan kan, bila tak kena pada level pergerakan planet apa semua kan. Cuma bila yang Einstein tu lagi dia
okay, so let's say let's take that as a specific example lah. Katakanlah you have your Newtonian calculation kan, and then you see planet ni lari sikit lah. What's the first thing you would do? You would say there's probably another planet you don't see. Betul kan? It's a simple explanation. Dia tak adalah kata salah yang Newton. Macam you gonna say it's probably something else that you don't see. I mean obvious kan benda tu kan. So I mean it's not as if benda tu tak jadi. Cumanya the weight of evidence for something to go against the established punya ni needs to be big. Needs to be big.
Kena berani apa.
Macam yang sekarang ni yang James Webb punya teleskop tu, data daripada tu is big enough such that dia orang kena revise the paradigm of the evolution of the stars tu kan. So they have a model, tapi data tu seems to suggest something else is going on. So dia orang kena tukar the initial conditions and whatever. So they have to change the so
tak semudah falsification tu tak
semudah tu lah. And even if you falsify, you may falsify certain parts je. Maybe you say the initial conditions are different.
Ikhlas lah.
Sebab remember in when you're doing science, there's always laws and initial conditions. Kan? So in your laws, you have principles, laws and initial conditions. You don't have to change your principles. The principle of conservation of energy has always been, I do not believe that anyone would get rid of that. It's very difficult to remove it. Your laws may change a little bit, tapi you can always change. The first thing you would think of is you change your initial condition. The initial condition includes yang tadi tu kan, the planet, additional planet tu initial condition lah tu. Kan? Because you say there's something else kat situ kan.
Okay.
So itulah macam
Prinsipal ni apa contoh? Level prinsipal?
everything is material. All physical phenomena have a physical cause. Kata lain, mukjizat tu mustahil.
Level filosofi of science lah kan? Level filosofi of science lah.
Filosofi of science lah.
Kalau terus mukjizat masih betul lah.
Mukjizat betul.
Ya, betul lah tu. Betul lah. Kalau ikut Prof, to me yang I was telling Ikhwan this morning, to me the principles live in level 1 yang Prof Pasal sebut tu.
Level 1.
Dia level 1. Dia kata level 1, level 2, level 3 kan.
Four mode
Dia ada level. Dia kata level 1 is like your worldview, and then you have level 2 which is your like ni, lepas tu comes to level 3 is your actual stuff lah which is going on. So in my opinion, it's either level 1 or level 2. I think it's level 1, your principle. No one's going to go against a lot of the principles. I mean, once you say, for instance kan, even macam kalau baca kan yang apa yang Shadrick tulis, apa dia panggil? Science delusion Science delusion kan dia kan buat eksperimen pasal extra sensory sense kan, extra apa tu, dia kalau dia buat dia kata kalau orang tengok tapi kita tak nampak, orang tu boleh rasa kan. Kan dia buat eksperimen tu kan, mana ada orang terima, orang tak terima, sebab that goes against like one of the principle, which is like you don't have physical punya interaction. How is it possible? Sebab
cuma eksperimen tu nak mencabar prinsipal lah.
Yelah, tapi mana ada benda keluar daripada mata ke? Apa benda yang keluar?
Itu terasa.
Macam mana dia boleh keluar? Kan, like as if intentional. So what you kind of have to say if you want to kekalkan prinsip tu is you have to say that somehow attention gives like a physical thing which then impinges on whatever your senses lah. So tu yang sebab tu dia masalah, because you have to make that assumption, and then it goes into consciousness. Dan consciousness benda besar, consciousness boleh jadi macam tu pula, then becomes a problem lah.
Kalau contoh macam dalam macam sanusi kan, dia bagi kita kan paper kan.
Tak baca ke? Okey. Dia tak baca.
Ada hukum akal, hukum syarak lah. Jadi biasa ada sains ni dalam
Hukum adat.
Tapi macam banyak kat abstraction, observation which involve the rational part lah. Jadi boleh kita bezakan macam tu? Adakah sebab macam Dr. Fah tadi, semua science is combination of adat and rational
betul. Saya rasa that categorization tu dia adalah untuk menyelesaikan masalah lain. Dia untuk menyelesaikan masalah kepastian. Kan, sebab dalam sekali apa dia nak buat ialah dia nak sampai kepada maratib kan. Maratib ilmu kan. Atas sekali lah tu kan. So dia sampai pasti kan, sebab hukum adat tak pasti. Kan? Tapi so sebab tu, tapi tool dia punya alat dia ialah logik. Kan? So last kali dia pergi kepada definisi badihi. So last kali the reason dia jadi pasti ialah sebab dia badihi. Kan? So sebab hukum adat tu tak badihi, therefore dia tak pasti lah. So dalam case science, what you do is kita guna hukum akal insofar as this is my own understanding lah. Kita guna hukum akal insofar as benda tu is objects of logic. In other words, so long as you can make it an object of logic, then you can use logical operations. So saya macam nak tulis lama dah, tapi tak sempat nak tulis lah. Tapi saya rasa in that sense macam science it's apa dia panggil, the physical sciences at least are objects of mantik. Cuma dalam method mantik tak ada verification, empirical verification tak ada. Tu je.
Tasdik yang berlaku tu adalah secara akli lah.
Dia tak ada. Kalau Kalau saya macam sepatutnya ada satu lagi level. So you have macam tasdik. Okay, sampai sini ni boleh test. Kalau test ni dan belakang tu betul. Tu kan? Kita macam tu kan.
So, apa semua kan.
So tu yang tak ada. Tak ada dalam ni lah. So whether or not the definition tu hard ke rasam ke, in some sense it does not matter at this point lah. Tapi for the method itself. So itulah macam, sebab ultimately you have your objects kan, which are definitions kan, and then you have your operations kan.
Tapi yelah, benda ni pun selagi tak selesai permasalahan problem of induction,
betul dia tak mencapai, okay, so dia tak mencapai pasti in that sense. Tapi dia bagi kerangka untuk faham sains tu macam mana kepada orang yang bukan dalam dari sains. Sebab if you say that, sebab ultimately if all of these things are objects of logic, then it should be apa nama ni, operationable by logical operations kan. If it is operationable by logical operations, then dia mantik lah. Kan, sebab mantik dia kan ada dua definition kan. Yang definition awal tu kan, secondary intelligible kan, yang pasal tu kan. Cumanya lepas tu dia jadi benda lain lah. Dia jadi rada maujud, jadi maklum kan. So my own opinion is macam, tapi if you wanna say mantik is still science is still mantik, you have to add that experimental part.
Yelah, cuma dia saya faham saya macam dia mantik pada aspek logik positivism.
Bukan, dia mantik dalam proses.
Yelah, maksudnya untuk sampai dia,
if you posit,
kalau saya bagi saya level kuli yang natijah kuli yang dicapai takkan sama dengan natijah kuli pada yang akli tu. Sebab pada macam doktor sebut tadi tu lah, pada level kepastian dia pun
okay, sebab okay, last sekali dia kuli sebab number one dia badihi, number dua dia kuli. Maksudnya dekat premis tu dia badihi dengan dia kuli kan, sebab tu dia jadi kuli kan. Tapi kalau dia kuli tapi dia tak badihi, dan dia tak jadi badihi, dia tak jadi certain lah. Itu je lah, which is fine. Okay, tak apalah macam tu. So it's fine lah.
Maksudnya tak level burhan lah.
Dia tak level. Okay, so it's not supposed to be that. So at least insofar as method is concerned, dia punya tugas ialah untuk memperihalkan alam. So long as, in other words, so long as your definitions are that, then katakanlah, okay, let's say your wave is something which follows your wave equation. Let's say that's your definition of your wave kan. So long as that, then it works out lah. Tu je lah. Cuma mungkin kita dapat daripada cerapan lah. Tapi itulah, kalau kita, okay, so here comes the problem lah. Kalau kita dapat daripada cerapan dan dia saluran ilmu, so dia badihi ke tak badihi, itu cerita lain lah. So then dia jadi pembentukan apa, the formation of definitions. So your formation of definitions ni kan, siapa ni, Ibnu Taimiyah pun kritik juga kan. So itulah, nak kena tulis at some point, tapi tak tulis sikit tak sempat, sebab banyak benda nak kena tengok. Faham kan dia punya logik kan. I think yang macam a lot of things has been said lah pasal logic and whatever kan. Masalah dengan logic modern ni ialah a lot of it is all about structure. Macam, you know, if you open a textbook on modern logic, all of this weird symbol kan, which like okay fine lah. Tapi all of the weird symbols are structure. Structure maksudnya benda yang kita boleh bina kan kat atas tu. Meaning is not there. Kan, meaning is not there. So structure is fine. Structure is good in that dia boleh uncover benda baru. So ChatGPT is just a structure in some sense. And the reason it works is because the meaning is provided by human beings. Kan? So if you look at the token kan, a token on its own does not have meaning. Sebab like if you think about meaning, it means, at least according to Prof. Alatas lah, dia bermaksud benda tu dia ada, kita faham dekat mana dia duduk dalam satu kerangka kan. Token tu mana ada maksud apa kerangka dia Kita tak ada kerangka kan. So the meaning tapi dia boleh uncover structure. Sebab dia ada all of this stuff going on kan. And then dia nampak ni ada jalan macam ni. So ni dengan ni berkaitan. Macam tu lah. Dia tak ada, dia doesn't give meaning pun sebab ultimately benda tu tak ada apa-apa lah. Dia. So my opinion is in that specific case, it is wrong to use the words knowledge dekat ChatGPT tu. Sebab dia tak ada makna.
So dia apa?
Dia maklumat lah.
Structure, maklumat yang structure.
Structure lah. Tapi tu cerita lain lah. Terus like aku tengok. Tu pun tak berfikir lagi.
Macam ni tadi saya tadi pasal yang adat dan
Akal.
banyak frame-frame istilah kita pun dia guna kat situ. Contohnya tarikh mujizat adalah apa yang
Melawan hukum adat.
mencari adat penilaian. Tapi sebab
Dia isu dia satu je pada mujizat tu kan, yang menjadikan kepada wujudnya pembahagian sedemikian lah.
ada juga lain. Contoh macam banyak prinsipal-prinsipal yang dibahagikan ni adalah perkara yang logik, very akli, which means mesti macam tu. Dia tak boleh tak macam tu.
Katalah kalau tak ada mujizat, fenomena tu kita akan kata mesti macam tu.
In a way, betul.
Kan?
Contoh macam api tu membakar, dia kata tu ada sebab ada kisah Nabi Ibrahim. Kisah Nabi Ibrahim. Jadi sebab tu dia kata api tak pasti membakar, tapi saintifik pun cakap ada juga qualifier kan.
Api yang tak bakar.
Dia memang ada scientifically proven.
Api tu apa? Api. Okay lah, let's put it. Let's go there lah. Specifically untuk api. Api tu apa?
Chemical.
Tak, dia benda ke dia fenomena?
Fenomena. Fenomena dia membakar.
Benda bakar. So emergent properties dia apa? Api. Saya tak dengar. Bakar emergent.
Dia tanya orang Bayu, dia tahu api apa api?
Oksigen. Apa yang membakar lah.
Energi yang
Api ada energi.
Apa yang membakar? Tidak elektrik.
Tak, dia benda ke bukan? Api tu benda tak?
Api tu
Okay, put it another way. Warna tu wujud tak?
Warna tu seperti mana mata kita. Warna tu ada, tapi
Warna, okay, dia spektrum of light kan? Okay, warna coklat, apa dia punya wavelength? So the problem is this. The problem is we want to say ni macam masalah orang moden lah. Kita nak kata apa yang wujud tu apa yang ada fi kharij je. Kan, as if warna clearly wujud, like you see it. Macam pernah cakap kan. Tapi you would say yang macam it's a sense data which is intermediated lah to a certain extent dengan kita punya faculties of sight. Api tu sebenarnya bukan benda. Api tu ialah kita punya interpretation of certain things which are happening, certain chemical punya processes. Jadi kita nampak dia sebagai api. Instrumental lah. Sebab benda tu jadi, cuma kita nampak dia macam tu. Api tu bukan benda. Api tu is a phenomenon. Bukan benda, maksudnya it's not a thing. It's not. Dia bukan zarah. Dia bukan zarah. Dia ni benda kan. Macam ni benda kan. Dia bukan benda. Dia macam fenomena.
macam air tak?
Macam basah lah. Basah real kan.
tapi
licin.
bukan ke fenomena tu membakar. Api tu benda.
Boleh dua-dua juga. Dua-dua fenomena.
Dia sedar.
Kenapa api tu menjadi fenomena?
Gas berubah daripada air cair jadi gas yang excite. Dia jadilah macam api. Dia bukan api, dia adalah gas yang excited. Molekul gas yang excited.
Air bukan macam tu juga. Bila chemically adanya H2O interaksi benda ni,
molekul bond
pada satu level adalah fenomena interaksi H2O tu lah.
Ya.
Jadi dia bukan
Dua fenomena.
bukan benda lah air tu.
molekul air.
Molekul air lah benda.
Molekul dia tu lah.
Tapi sifat air
Sifat
membasah
air basah tu, kita panggil dia air kan. Kita macam ni air kan.
Macam tu juga api.
Ha?
Macam juga api.
Yelah, tapi dia bukan benda.
Okay. Tapi pada level molekul adalah benda.
Ha?
Pada level molekul adalah benda.
Benda.
sifat basah
Dia like chemically macam H2O tapi tak tahu.
Benda lah, dia benda. Tak tak? Air H2O tu benda.
Ha.
It's a thing.
Api?
Api is like, I don't know, like some, apa dia panggil, electromagnetic punya radiation or something like that, which is like coming out of that. Dia bukan plasma. Plasma is a different state of matter. Plasma ni jadi bila kita panaskan satu gas such that elektron tu terkeluar daripada atom tu, dia jadi plasma. Itu jadi plasma. So dia fenomena. So dia fenomena because we see it kan. Tapi the fenomena tu dia jadi makulat ulu lah kan.
Maksudnya sekarang ni bukan kebakaran je fenomena. Api tu
Apa tu dia fenomena?
sendiri.
Jadi banyak level fenomena kan.
Perbahasan causation tu bukan antara dua api yang kena benda tu lah. Untuk berlaku api tu mana perbahasan
Ada pasal lain lagi. So dalam so
Ada ke benda dalam sains ni yang memang rasional, yang memang it is never mesti macam tu?
ada axiom lah. You can reject the axiom. You can reject the axiom.
Exam tadi tu lah yang principle.
tak. So macam mana kata?
Prinsipal tu ada kan level axioms in science.
Dia macam different levels of axioms lah. So you have like very general principles kan. For instance, everything is material kan. So that's a very general principle. Ataupun apa nama ni, apa dia panggil, cause and effect. Cause and effect is necessary kan dalam sains. A very general principle. Everyone, siapa yang buat sains tak percaya benda tu pelik lah, like then kau buat apa? Kan. And then you have like lower levels of principles lah, ataupun laws atau what we call it. I don't think yang macam the distinction between laws dengan apa dia panggil lagi satu, laws and theory tu is that straight. I've not macam I say, siapa nama ni, Haziq ajar dia cakap macam, oh, no, theories come first, and I don't think it's that easy, so to speak. I think what happens is certain things you elevate. I think
Teori hukum bisa.
macam hukum Newton, hukum gas kan, ideal gas law kan, PV sama dengan NRT kan. Siapa kata dia hukum kan? What's the difference hukum dengan teori? Susah nak cakap kan. Tapi in any case, macam I think there's different levels of axioms which work for different things. Ultimately what it is dalam kes Sanusi tu ialah dia nak menyelesaikan satu masalah, as in it wants to get to something kan. Science pun wants to get to something. So in order for it to get to that thing, which is memperihalkan alam, it uses whatever it needs to use, including hukum adat, including hukum akal. So the distinction between hukum adat dan hukum akal tu, in some sense, bukan yang dia tak berguna, dia guna, tapi guna dalam kes Sanusi lah. Dalam kes sains, kita guna dua-dua sebab ultimately what matters is we wanna memperihalkan hukum adat ni lah.
I don't guna Sanusi framework untuk memahami Sains Moden. Susah sebab mana ada sains yang berbasar akal atau rasional punya.
Kan. So kalau kita nak kata there is a clear demarcation antara hukum adat dengan hukum akal, memang tak ada lah dalam sains. Sebab clearly, sebab hukum akal tu ialah logic kan. Logic kan. I mean, kalau kita guna induction pun to a certain extent is logical. Cuma kita punya, okay, katakanlah evolution kan. You see this. Dua ni lebih kurang sama. Kan? So that's one of your premises. You have to have another premise. And then you say, therefore, this is an extension to this. Kan? So if you accept those two premises, then you would get, I mean, fine lah. Maybe you will reject that premise. Tak kisah lah. Tapi that sequence tu is logical. So from my understanding, yang hukum adat ni dia correlation, lebih kepada correlation lah yang sentiasa berlaku.
Betul. Dia lazim, dia biasanya.
Melazimi kan. So kalau nak tengok discussion tu, apa beza antara correlation dengan causation is a third cause, a third common cause. So if you can explain the correlation of two things using another one, then you say that those two are caused by this. So that's one of the ways in which you do that. There's several ways of doing that. Tapi itulah Allah tak tahu betul ke tak kan.
Bila kita cuba faham apa yang hukum anda adalah sains, it's not really
Tak boleh
Apa ni pun kenapa nak dimarketkan sains?
Even kalau dulu pun macam orang kata macam kalam tu bukan sains ke? Betul, kalam memang sains. Tapi sains bukan ada satu benda je tau. Instrumentation pun sains juga. Kan? Macam contoh daripada idea yang semua cahaya tu ialah electromagnetic wave kan. Macam mana kita buat alat daripada tu? Itu instrumentation, still kena buat kajian ni. It's still within the remit of science walaupun mungkin towards technology. Tapi ada benda-benda yang kita tak tahu tau. Still kena kaji lagi. Kan? So even with that, then you still have to, kalau dalam Islam benda tu masuk handasah, mana ada masuk kalam kan, whatever benda ni kan. So dia macam ni, dia kategori error lah in that sense. Categorical error. In the same way yang bila kita bercakap, bila orang Mat Saleh bercakap pasal, especially Christians lah, bila dia orang cakap pasal abortion, dia jadi isu sebab Nabi Isa. Dia jadi isu sebab dia orang percaya that the soul is macam mana, is co-created ke macam mana with the ni. Dia jadi isu sebenarnya tu. Dalam Islam mana ada masuk kat situ, dia masuk dalam tempat lain. Di mana dia masuk dalam teologi? Kan? Tak ada kena-mengena pun. So kita masuk tempat lain. So tu lah macam Prof Hasan dia cakap yang macam kita kena ada orang yang sains dengan orang yang agama kan untuk bercakap. Sebenarnya kita ada, pada saya kita kena ada someone yang boleh bercakap dua-dua bahasa. So
Harmoni kan lah.
So dia bukan harmoni kan, dia nak explain orang ni cakap apa, orang ni cakap apa, orang ni cakap apa, orang ni cakap apa.
Jadi takkan boleh harmoni.
Tak. Benda ni jadi saya baru je ada discussion dalam sains pun jadi. Contoh kan, saya bagi contoh dalam pernah dengar doped, DOPED, macam semiconductor ataupun dope gelas kan, terdop kan. Okey, dope ni bila kita cakap kaca, maksud dia lain. Bila kita cakap semiconductor, maksud dia lain. So dalam semiconductor, it means yang macam when we say something is doped, katakanlah kita ada silicon, we want a dope silicon. Sebab semiconductor ada dua, dia ada dope dengan dia ada alloy. Okay, semiconductor yang ni senang. Lampu ni semua gallium nitride, contoh kan. So when we say we dope gallium nitride, what we mean is we are going to change one of the atoms with an atom with a different valence of. So that's what it means dalam semiconductor. Dalam kaca, maksud dia ada kaca kita letak benda yang aktif. Okay, so baru ni we had a discussion where someone who was doing glass cakap pasal doping, tapi dia cakap dengan orang semiconductor. Orang semiconductor tak faham. Dia ni cakap apa? We don't do doping like that. So dia kata macam no. So someone has to come and say no, this is what it means in semiconductor, this is what it means in glass, and what you're saying is the same. In semiconductor, what this is, we would call that something like a phosphor lah, untuk keluarkan cahaya lain. So the function of that is to make it as phosphor. Sama je. I mean, whenever you have the same thing macam atom, so kan, atom dalam fizik maksud lain, dalam kalam maksud lain kan. So you always need someone who say, hang on, what does this mean? What does this mean? Then okay, this is what this means here. This is what this means here. And then is it the same? If not the same, then maybe you need to do something else and stuff like that. And nak buat tu ialah susah lah sebab you need to learn.
Bila sekarang yang berlaku ni masing-masing yang dalam bidang ni, yang ni nak masuk dalam sempadan. Jadi
which is fine lah. So at least there's interest kan. Cumanya you need to disentangle lah.
Interaksi tu dalam keadaan tak matang lah, tak difahami dengan betul.
Dia miscommunication. Kalau ikut Ikhwan dia kata kita kena buat macam dictionary lah, macam like a translate ni macam ni, translate ni macam ni, translate macam ni.
So kira sebenarnya sensor
Penat cerita sains tu apa?
Nak define balik dan give conclusion.
Okay, conclusion dia. Sains tu ialah satu aktiviti manusiawi untuk memahami mekanisme alam.
Aktiviti
aktiviti lah, aktiviti manusia lah.
Dia method, satu method.
Aktiviti termasuklah method. Dalam sains tu dia ada certain assumptions and certain very specific methods dalam sains tu, including the assumption that everything is material, sebab musabab tu is necessary and stuff like this. In order for you to be able to memperihalkan alam, kita kena posit certain things about nature. In other words, kita ada benda kan, so kita kena cakap something pasal benda tu keras ke apa, properties benda tu. That is also the object of investigation as well. So a lot of science is also investigating that. So the mechanisms and then the nature of how things work, as it were. Now, when in the course of doing that, what tends to happen is you confuse epistemology with ontology. You make certain ontological claims that maybe you don't have to make. Maybe you're taking to me. So sometimes interpretations gets too far. Some of the axioms are taken as self-explanatory when they really shouldn't be. So sometimes this is where the problems are.
Scientism.
Not necessarily. Sometimes just because it's reasonable to do that.
Oh, okay. Betul.
Kan, kalau kita lukis peta dan peta kita betul sampai kepada satu tempat, then obviously kita kata betul lah, jalan ni betul lah, bentuk macam ni kan.
Faham.
So in the interaction between agama dengan sains ni, sometimes for a lot of the time, for a lot of the cases, dia tak campur pun. In that macam a lot of the technical punya stuff, day to day punya stuff, dia tak impinge pun dengan apa yang agama cakap. Cuma ada certain key things yang bermasalah, dan yang tu yang kena difahami lah. Among other things including evolution lah. Evolution memang besar lah. Itu bukan kita nak cakap. Yang tu honestly tak nak cakap.